Hello and welcome back to Jacubication. This is the next video of Chapter 0 entitled Stacks and Recursion. Stacks. A stack is an abstract data type that is a collection of items with two operations, push and pop. The stack ADT is LIFO, or last in, first out, meaning the most recent item placed in the stack will be the first item to leave. Push adds an element to the stack, and pop removes an element from the stack. With just this definition, you're tempted to say, who cares about this abstract thing? This and other ADTs play roles in solving certain types of problems. Palindromes. A palindrome is a word or phrase that is spelled the same forwards and backwards. You can see if a word is a palindrome using a stack. Basic solution. Have a copy of the initial word, push letters of word one by one onto the stack, pop all the letters back out and collect them into a new string in the order they are popped out. If the new string in the previous copy matches up, then the word is a palindrome. Animation 1, ball. Add B-A-L-L to the stack, pop them off, remake the string. You'll get lab. Lab doesn't equal ball. Ball is not a palindrome. B-A-L-L. L-L-A-B. Lab doesn't equal ball. Ball is not a palindrome. Racecar. Add R-A-C-E-C-A-R to the stack. Pop them off and remake the string. Racecar does equal racecar. Racecar is a palindrome. R-A-C-E-C-A-R. R-A-C-E-C-A-R. Racecar is a palindrome. Revisiting variable function scope. Stacks were the concept I previously alluded to that you needed to know to understand this. The computer itself in most languages has a stack that stores stack frames. A stack frame is added to the stack when a function is called. It stores arguments and variables local to the current function you're in, and the current function itself. Def main, x equals add 1, 2, return. Add a, b, return a plus b. Call main. Main is added and it says x is going to be the result of calling the add function with 1 and 2. You pop another stack frame on with the add function and it tells you you're going to return 3. 3 is given back. X now equals 3. The add function has no concept of the x variable. Therefore, variables most of the time only exist in the function they're defined in. One exception is global variables that you declare outside of any functions. Global variables can be anywhere from frowned upon to totally disallowed by a language. The other exception is block-scoped variables, depending on if the language supports it. For example, a variable defined in an if block only exists within the if block. Revisiting recursion. The only thing different between that palindrome example and recursion is who's using a stack. In recursion's case, the computer is using a stack. Recursion relies on a function having two things, a recursive case and a base case. Recursive case, the part of the function where it is still calling itself. Base case, the part of the function where the answer to this call is known trivially. The stack can start popping frames off at this point. The following examples will be either examples of single or multiple recursion. Single recursion can often be easily replaced with a loop. Factorial. The classic recursion example, factorial of 5, is demonstrated. Factorial of 5, you return factorial of 4 times 5. You got to do the function call before you can return anything, so you call factorial of 4. Factorial of 4, return factorial of 3 times 4. Again, you got to do factorial of 3 first. Factorial of 3, return factorial of 2 times 3. Again, you got to do the function call first. Factorial of 2, you return factorial 1 times 2. Again, function call first. Factorial 1, you return 1. You hand the answer back of factorial 1 to the previous function. Return 2. You hand that answer back to the previous call. You return 6. You hand that answer back to the previous call. You return 6 times 4, 24. You return that answer back to the previous call. And factorial of 5 ends up equaling 120. Reversing a string. Reversing cat. Single recursion again. You do T plus reverse CA. A plus reverse string of C. C plus reverse string of empty string. Reverse string of empty string. You return the empty string back. You return C. A plus C. You return a plus c to t, and you end up returning tac, because that's cat backward. Multiple recursion. In multiple recursion, a function can have multiple calls to itself within one call of the function. This means the function ends up following the first call first. Then when a base case is reached, the second call is later followed as stacks frames are being pushed off. Fibonacci. If n equals 0, return 0. If n equals 1, return 1. Else, return Fibonacci of n minus 1 plus Fibonacci of n minus 2. We're going to demonstrate Fibonacci of 3. This gets inefficient because you're asking the same question more than once. Fibonacci of 3, you got to return Fibonacci of 2 plus Fibonacci of 1. So go to the left call first. Fibonacci of 2 is Fibonacci of 1 plus Fibonacci of 0. Left call first again. Fibonacci of 1 is 1 and give that answer back. You got to call Fibonacci of 0. Fibonacci of 0 is 0, give that call back. Fibonacci of 2 is 1. Give that call back. Now you got to work out what Fibonacci of 1 is again. Fibonacci of 1 is 1. Give that answer back. Fibonacci of 3 is 2. Final note on recursion. The utility seems hazy at best, I know. At this point, your best bet is understanding the concepts, not remembering how these examples worked out. In the next video, I'll cover cues. Ciao.